Here is Donald Trump at the United Nations on September 23rd, 2025.
It's the greatest con job ever perpetrated on the world, in my opinion. Climate change, no matter what happens, you're involved in that. No more global warming, no more global cooling. All of these predictions made by the United Nations and many others, often for bad reasons, were wrong.
So who is actually perpetrating a con job here? Is it the thousands of independent scientists around the world who have been studying Earth's climate in detail for decades? Or is it the president who once had to settle a class action lawsuit brought against him by thousands of students who felt defrauded by his now defunct Trump University? Hi, I'm Steve Vigdor, and this is my friend Tim Landergan. We're both retired professors of physics at Indiana University, and we co-write a blog which we call Debunking Denial, in which we try to clear up misconceptions and misinformation and disinformation that's spread about a wide range of controversial issues at the interface of science with public policy. The views that we express on our blog and in these videos are our own. They're based on a combined 100 years of experience as working forefront scientists, and they don't represent in any way positions taken by Indiana University. So this is the first of a series of short videos we're going to make about global warming and climate change, where we're going to try to present to you the basic science behind global warming and how humans are contributing to it, short-term and long-term impacts of the consequent climate change, and what humans can do to mitigate the worst impacts. And we're going to try to do all this as straightforwardly as we can. Before we get started, I want to thank everybody, each and every one of you who's tuning in, because we think it's really important to address these important issues head on, backed by real science, as opposed to hiding behind denialism or pseudoscience. And with that, I'm going to turn it over to Tim to get started on telling you something about the basic science of global warming.
Thanks, Steve. In both his first and current administrations, Donald Trump has perpetrated a number of misinformation and denial statements regarding global climate change. In his first administration, Trump asserted that global climate change was a Chinese hoax. But in his second administration, they've taken many more seriously dire positions regarding climate change. First, they're plowing ahead, full steam ahead on use of fossil fuels and expansion of that. At the same time, they're actually trying to crack down on the use of renewables and research into renewables. These, as we'll show in this and later videos, can have extremely dire impacts on our planet. So in this video will show the following. First, global warming is real and can be explained by simple physics. Secondly, the primary cause of global warming is human activity. Third, we can understand global warming without resorting to complex mathematics or sophisticated climate models. And finally, even in these sophisticated climate models, they cannot explain the trends in global warming today without including a dominant contribution from greenhouse gases. Now, one simple physics fact we've known for almost 200 years is that heated bodies emit electromagnetic radiation. So if you've ever seen a heated iron rod, it's glowing, and the glowing is a sign that it's emitting electromagnetic radiation in the red visible part of the electromagnetic spectrum. Now, heated bodies emit electromagnetic radiation in a spectrum of wavelengths or frequencies. The frequency of a wave is just the speed of the wave divided by the wavelength, so that frequency or wavelength are equivalent ways of describing the properties of electromagnetic waves, and we will use wavelengths in this talk. So the sun is a hot body. Its energy is generated by nuclear fusion reactions deep in the core of the sun, and the surface temperature of the sun is just slightly under 6,000 degrees Celsius above absolute zero. We've known for over 100 years that the properties of the electromagnetic radiation coming from a heated body depend only on the surface temperature of that body. So since the sun's surface temperature is about 6,000 degrees Celsius, the spectrum of radiation emitted by the sun is predominantly in the visible and ultraviolet regions. The Earth, on the other hand, is also a heated body. Its surface temperature is just under 300 degrees Celsius above absolute zero. Hence, the electromagnetic energy radiated by the Earth is in the infrared region of the spectrum. The radiation coming from the sun being in the visible and ultraviolet, our atmosphere is essentially transparent to those wavelengths, and therefore the bulk of the energy emitted by the sun coming towards the Earth comes straight through the atmosphere and onto the Earth. An exception to this is the very high ultraviolet region. Those very high ultraviolet rays are absorbed in a level in the high stratosphere called the ozone layer. It's a good thing for us that they are absorbed and never get to Earth, because they would be toxic, they would be fatal to humans or animals. On the other hand, we have substances called greenhouse gases in the atmosphere. Examples of greenhouse gases are carbon dioxide, water, ozone, nitrous oxide, or methane. Greenhouse gases are transparent to visible and ultraviolet rays, but they absorb energy at certain wavelengths in the infrared. So the electromagnetic radiation coming from the Earth heading out towards space at certain wavelengths is absorbed by these greenhouse gas molecules. It's then re-emitted. However, the radiation coming from the Earth is headed for outer space, but the re-radiated energy from greenhouse gases is re-radiated in all directions. So some of that escapes out to space, some of that goes into the atmosphere, and some of it comes back and provides additional warming for the Earth. Now, these greenhouse gases therefore act sort of like a thermal blanket in radiating electromagnetic energy back to the Earth. It's a good thing for us that this is the case, because if there were no greenhouse gases in the atmosphere, the temperature of Earth would be about 30 degrees Celsius or 54 degrees Fahrenheit colder than it is now, so we would be freezing. However, at the moment, the amounts of greenhouse gases in the atmosphere are too high. Therefore, this re-radiated energy is too much of a good thing, and it's causing the global warming on Earth. Now, the figure we show here, the red curve is the power per unit area as a function of wavelength that would be emitted by the Earth at its current surface temperature. The blue shaded region, on the other hand, is what satellites measure as the radiation that actually escapes the atmosphere. As you'll see, the blue shaded area is substantially below the black body emission curve for the Earth. And in particular, this blue region has several deep minima, and those minima correspond to wavelengths at which various of the greenhouse gases absorb radiation and re-emit it. You see, in particular, a very deep minimum right near what would be the peak of the radiation from the Earth, and that's due to absorption by carbon dioxide. Now, the current level of carbon dioxide in the atmosphere is 428 parts per million. That is, it's less than 0.1% of the atmosphere. Many climate change deniers say, therefore, CO2 cannot be the cause of our global warming primarily because there's so little of it. However, that statement is false. If you do a calculation, you can see that 428 parts per million of CO2 corresponds to about 6,000 trillion CO2 molecules per cubic centimeter halfway up the troposphere. The troposphere is the part of the atmosphere closest to Earth. So there's plenty of carbon dioxide to provide that warming. Now, the next graph we show here is a graph of the abundance of carbon dioxide in the atmosphere as a function of time, going from the current day, the right-hand edge, to 800,000 years ago. How do we know what the carbon dioxide levels were going back 800,000 years? Well, we can take ice cores from the Antarctic. And the deeper you go in these ice cores, the longer ago the ice was laid down. And we can study bubbles which are trapped in these ice cores. And by analyzing the bubbles, we can tell what the CO2 levels were at that point in time. So you see several striking things in this graph. First of all, there are substantial maxima and minima in this curve relating to climate changes on Earth over that period, including many ice ages. The second is that the CO2 abundance is bounded. It never gets less than about 180 parts per million, and it never gets more than about 280 parts per million. However, you see right at zero, the current day, you see that CO2 levels have rocketed upwards to levels that have never been seen in the past 800,000 years. In 1911, the abundance of CO2 was 300 parts per million. In 1958, it was 340 parts per million. And today it's 428 parts per million. So Steve will now tell you what implications we can draw from that, how we know that this is human activity, and we'll start to discuss why this situation is so dire.
Okay, thanks, Tim. When humans burn fossil fuels, that's oil, natural gas, or coal, it emits carbon dioxide into the atmosphere. And when carbon dioxide is in the atmosphere, it remains there for many decades. And since the Industrial Revolution, humans have been emitting carbon dioxide. They've been burning fossil fuels at a steadily increasing, in fact, an exponentially increasing rate. On the graph on your screen now, you can see that in the blue curve. The blue curve shows you how many billions of metric tons have been emitted of carbon dioxide from fossil fuel burning by humans from 1750 on the left to the present day, or earlier this century, at least in this particular graph. And you'll see that the blue curve rises very rapidly. In fact, this curve ended earlier this century. Today, as Tim said, that blue curve rises to about 428 parts per million. Correspondingly, so this is more carbon dioxide emitted from Earth than can be absorbed by all the vegetation on Earth. What that means is that a lot of the carbon dioxide ends up residing in the atmosphere or in the oceans. And the brown curve on this graph shows you what the concentration of carbon dioxide, the measured concentration of carbon dioxide is in the atmosphere over that same stretch of years from 1750 to this century. Before the Industrial Revolution, and in fact over the entire 7,000 or 8,000 years of human civilization, that level of carbon dioxide in the atmosphere was very stable at about 280 parts per million. But since humans have been emitting carbon dioxide from fossil fuel burning in the blue curve, the brown curve has started to rise correspondingly. It's human burning of fossil fuels that is responsible for this increase, which is now getting pretty rapid and ongoing in the brown curve, the concentration of carbon dioxide in the atmosphere. So the carbon dioxide level in the atmosphere is now 1.5 times as high as it was in the pre-industrial era. And the same is true for methane, by the way. So greenhouse gas concentrations are increasing, and they're increasing rapidly as we burn fossil fuel. And from what Tim showed you, if you increase carbon dioxide and methane in the atmosphere in that spectrum that we showed you, the shaded blue area of how much infrared radiation reaches Earth's satellites, the dips get deeper as you add more concentration of greenhouse gases in the atmosphere. If the dips get deeper, that means that more heat is being returned to the surface of the Earth. There's no way around that. That's straightforward and simple physics. That means that the surface of the Earth is getting warmer. So how do we know? How do we measure that it's actually getting warmer? Well, there are many thousands of monitoring stations all around the globe where we measure surface temperature over land and sea. And what you see on your screen now is a series of maps provided by NASA which show you what the annual average temperature is at various points around the globe and as a function of time. So the upper left plot is for a 4-year average around 1970. The upper right is around 1986. The lower left around 2002. And the lower right around 2019. And in these maps, blue regions are cooler than the average used to be in the middle of the 20th century, and orange and red regions are hotter. And what you see here is that as time has gone on over the last half century or so, the entire Earth has been warming. The average by which that has been warming is more than 1 degree Celsius now, but as you see from the lower right, in the polar regions, the high northern latitudes near the Arctic, the warming has been much stronger, by about 3 degrees Celsius, or equivalently more than 5 degrees Fahrenheit. So the Earth has been warming, and it's been warming globally. We actually have ways of looking at proxies that tell us what Earth temperatures were in various regions of the globe going back thousands of years. And we have no evidence that humans have ever been exposed to a global phenomenon like this. The global warming is a new phenomenon, and except for tiny regions you can see in the lower right that are blue, which we may explain in a later video in this series, it's the whole Earth that's warming. So how much has it been warming? This next graph that you see is from the Berkeley Earth team. And what it shows, the spiky stuff in the background, forget about the solid black curve for a moment. I'll come back to that soon. The spiky stuff is the best determination we have of annual average Earth temperature going back to 1750 and up into this century. And the way that's been measured is by averaging over monitoring stations, climate monitoring stations at all parts of the globe, and averaging over night and day and all seasons. The Berkeley Earth project, by the way, was started by climate skeptics. It was started by physicist Richard Muller and his daughter Elizabeth. And Richard Muller started out very skeptical of previous attempts to plot out the trend of global temperature, because he thought that a lot of the monitoring stations that had been used previously by people might have been giving skewed results. But he took this skepticism and he approached it scientifically. What that means is that he and his team decided to add in many thousands of additional climate monitoring stations around the globe. So they had many tens of thousands of monitoring stations. They used the latest statistical analysis method. And they had so many stations that they could subdivide the entire group into subsets. For example, all urban stations versus all rural stations and other subsets. And then they could compare the results that they found with different subsets to see if there was a skew. What they found, not very surprisingly, was that urban stations systematically measured a higher absolute temperature than rural stations. You may have heard of this. It's something called the urban heat island effect. But when they looked at the change in temperature over years, they found exactly the same result for urban stations as they found for rural stations. So for the change in temperature, it doesn't matter. They could put all of the monitoring stations back together, and then they obtained this curve, which shows that from 1750 to the present, the average global temperature on Earth has risen by about 1.5 degrees Celsius, and most of that rise has occurred over the last 50 years. The other thing that Richard Muller was skeptical of were the very complex climate models that climate scientists were using to attribute this trend in temperature to human activities. So what he decided to do instead was just to compare one set of measurements against another. And what's seen in the black curve on this graph is the scaled up atmospheric concentration of carbon dioxide that you saw in a brown curve on a previous graph. And what Muller observed is that the trend in global temperature matched the trend in atmospheric carbon dioxide, and those are measured completely independent of one another. It matched it almost perfectly. That match was enough to convert Richard Muller from a climate skeptic into a climate change advocate. What you may also see on this black curve, if you look closely, is that there are these occasional narrow dips. Those dips correspond to the eruptions of major volcanoes, which are known, and in fact, most of them are actually labeled in blue on this graph. Volcanic eruptions cool the Earth a little bit for a short amount of time. The reason for that is the eruptions from the volcanoes include sulfur dioxide aerosol particles, little bubbles that rise into the stratosphere, and those little bubbles reflect sunlight. So that when those little bubbles are in the atmosphere, there's less sun that reaches the surface of the Earth. It reduces the solar heating of the Earth, so it reduces Earth's temperature, but only for about 2 or 3 years because those bubbles disappear after 2 or 3 years. So you see a series of narrow dips, but it doesn't change the overall trend, which comes from the increasing concentration of carbon dioxide and methane and other greenhouse gases in the atmosphere, and that comes in turn from the human burning of fossil fuel. You can see the correlation even more clearly on this next graph, which also comes from the Berkeley Earth team. Here, what they've plotted is on the vertical axis, it's the measured global mean temperature, versus on the horizontal axis, the independently measured carbon dioxide concentration in the atmosphere. And the rainbow-colored dots represent the values of those, that mean temperature and carbon dioxide over years from 1850 to the present. And what you see is an extremely close correlation. And we know from simple physics that as you pump more greenhouse gas into the atmosphere, the Earth has to warm more, and that correlation is going to continue to rise. How it will rise, you don't need sophisticated climate models to tell you that. you can make simple extrapolations, which are done here in the red and the dashed black curves. Those are two possible extrapolations of the correlation that we've already seen for more than 150 years. The rise will not exactly be along a straight line. The reason for that is at some point you start to get so much greenhouse gas in the atmosphere that adding even more has diminishing returns. You're already absorbing so much of the infrared radiation from Earth that you can only absorb that much more. So the curves tend to bend down slightly. Now, deciding when we will reach various points on this curve, that depends on human activity. It depends on how humans address global warming. If we continue the current trends in how we're increasing carbon dioxide emissions, we're currently up to about, humans worldwide are emitting now about 60 million metric tons every year of carbon dioxide and other greenhouse gases. And that is rising rapidly. If we continue that trend, we will have doubled the atmospheric concentration of carbon dioxide, or gotten up to about 560 parts per million by about 2060. And at that point, the Earth will have warmed by about 2.5 degrees Celsius over the pre-industrial level, which had been essentially constant for 7,000 years, only fluctuating by about 0.5 degree Celsius. By the end of this century, if we continue current trends, we would get up to about 790 parts per million carbon dioxide concentration in the atmosphere, and the Earth will have warmed by nearly 4 degrees Celsius, or more than 7 degrees Fahrenheit. By that point, we would be living, or our descendants will be living, on a very different Earth, as we will tell you in subsequent videos in this series. And at this point, I'm going to turn it back over to Tim to summarize what we've told you so far.
Thanks, Steve. So here, let me summarize what we hope to have convinced you in this talk. First, the Earth is warmed both by the sun and by infrared radiation that's re-radiated back to Earth by greenhouse gases in the atmosphere, particularly carbon dioxide. Carbon dioxide released when fossil fuels are burned remains in the atmosphere for many decades, almost a century, and increases the global warming of Earth. Sophisticated climate models find no alternatives to explain global warming except for a dominant contribution from greenhouse gases. At the present rate of emissions, if we continue, the Earth will be roughly 4 degrees Celsius hotter than the pre-industrial level by 2100. Many people may say, well, 4 degrees Celsius, that's not so much. However, as we'll show in subsequent videos, that leads to very dire results in the near future and can lead to even more serious global tipping points, which we might reach if we continue these actions. In order to preserve a livable planet for future generations, we need to decrease fossil fuel production as rapidly as humanly possible. Expanding the use of fossil fuels at this point, as Trump administration is pursuing, is equivalent to the definition of insanity that's often attributed to Albert Einstein. Insanity is doing the same thing over and over again and expecting different results. So in conclusion, we pronounce Donald Trump's claim that global warming is the greatest hoax or con job ever perpetrated on Earth. We pronounce this debunked.